Hey everyone, welcome back to my video series on solving LeetCode problems. Right now we're solving the gas station problem. So what's it about? There are n gas stations along a circular route, so you just go around that route where the amount of gas at the nth station is gas of I. You have a car with an unlimited gas tank, so you can put as much gas as you want, and it cost of I of gas to travel from the I gas station to the next I plus 1 station. You begin the journey with an empty tank at one of the gas stations. You're given two arrays, gas and cost, and you need to return the starting gas station index on which you can travel around the route. If possible, you return that index. If not, you return -1. If there exists a solution, it's guaranteed to be unique, so you can't start in more than one place. So, you get an array like this, and you get something like this. So let me just describe the problem on Paint. So you have 5 gas stations, and let's see, it's 1, 2, 3, 4, 5 gas, so it's going to be $50. 1, 2, 3, 4, 5. This is the gas that you can put on each station. By the way, this is, let me just put, I need to decrease the size of the font. Station 1, and then I can just go and station 2, station 3, station 4, station 5. Cool. And now they are all connected like this. You can only go clockwise, so you can only go from 1 to 2, you cannot go from 2 to 1. And according to the cost, it's 3, 4, 5, 1, 2. So the cost is 3, 4, 5, 1, 2. So what does this mean? So we need to travel around this, and what's one way to see this? One way to solve it. So let's try station 1. So at station 1 we start with 0 gas, but we put the full tank, so we have 1 liter of gas. But then we try to travel to station 2, but we need 3 liters of gas to travel to station 2. So, done. We're done here. So, we know that station 1 is not an option. We can try station 2, and we see, oh, now I fill up the gas tank with 2, but I need 4 to travel. So, okay, station 2 is not good. Let's try station 3. I fill up 3, I need 5, no, but 4. I have a gas tank of 4, but I need 1. So I travel and I got a gas tank of 3. I fill up with 5, so 3 plus 5 is 8. I have 8, but I need to spend 2 to go here. So I have 6. I put 1 liter, I have 7, I spend 3, I have 4. I put 2, I have 6. 6 minus 4, I have 2. 2 plus 3, I have 5, minus 5, I have 0, but I just returned to the same station I started. So, station 4, this is a station that if we start here, we can reach it by going around the clock. So, we could just try all the stations individually until we find a station that we can go around. The problem is that if we do that, I try that, and it works, but it's too slow. And there's some cases where it just takes too long, and LeetCode says that the time limit was exceeded. So is there a way to make this faster? And actually there is. So there's like a kind of a cheat, as in let's not do all of them because we know that we don't need to. So let's start again from station 1. We try station 1. Actually, this is not a good example. Let's try with station 5. Let's just start with station 5. So we put 5 liters of gas. And that's good. And we try 5 minus 2 is 3. Plus 1 is 6. Minus 3 is 3. Plus 2 is 5. Minus 4 is 1. Plus 3 is 4. And then we can't. 4 minus 5 is minus 1. So we can't go from 3 to 4 if we start at 5. But there's something that we realize. So we realize that 5 is not a good option. So let me just put red here. It's not a good option. But we also realize that 1, we just started at 1 with 3 liters. So 5 minus 2, 3. We started at station 1 with 3 liters. And it was not possible to go around with, we just stopped here. And we started at station 1 with 3 liters. So imagine if we started at station 1 with just 1 liter. No, it's not possible. Given that, I think I can just say that, well, 1's not good. Same thing for 2, and same thing for 3. So, logically, I started at 5, then I would try 1, I would try 2, I would try 3. But I don't need to because I already know that they're not good starting points. So, I just need to start to try 4. And let's try 4, and as we saw, it works. So let's implement this. So I'm just going to delete this. So I'm going to start with impossible indexes, or indices, which is going to be a set of nothing. And I'm just going to return minus 1 in the end because that's what we need to return. And now, for a possible start point in range length of gas. That's gas and cost. They both have the same length, so I could choose either one. So possible start point, here we are. And what do we do here? So here we need to try to go around all of it. So current position is equal to possible start point. And current gas is equal to 0. So while true, I'm going to loop and say this. Current gas equals plus or equals the gas that we can put in the gas station that we're on. So gas at current position. And current gas minus equals the cost of traveling from that position to the next. So it's current position. So at this moment, we're like, okay, good. So if gas is smaller than 0, then we brake. It's like, okay, we can't do it. If not, then we just say, hey, the travel index, not travel index, sorry, the current position is plus equal to 1, and if it goes around, if length of gas equals current position, then we just current position equals 0, so we reset it to 0. One thing that we can do is just, if you want to make it more elegant, its current position plus 1 rest of the division by length of gas. I think we can do that just to make it elegant. And now we check if current position equals possible start point, means it went around, so we return possible start point. So that's what we do, pretty much. What we also need to do is we need to remember that thing that I said, oh, if we've been here, then we don't even need to start here. So I think we can say impossible indexes dot add current position, and we add it. And for possible start point, if possible start point in impossible indexes, we just continue, we ignore it. So let's get our example. Gas is 1, 2, 3, 4, 5, cost is this, and the output should be free. So run and debug. Oh, sorry. Current gas. Free. Okay, sounds good. Let's submit this. Okay, I didn't get such good results, but this is the logic. Let's just submit again and see if for some reason it does better. Well, it did a little bit better, but still not so good. Things that we could do to optimize, maybe we could just start by creating a gas minus cost array. So gas and cost equals x for x in how do you do that? X minus y for x and y in. There's something to Python iterate two arrays simultaneously. Zip, exactly, zip. Zip gas and cost. So maybe we can just go and say gas and cost at current position. Maybe that will just make it faster. Well, I made it slower. I don't know, let's check the solutions. What are people doing? Python, 2 to 6 lines. Complete the circuit only if the total amount of gas in the circuit is sufficient to drive the circuit, okay? Sum of gas must be equal or... Well, maybe I'm saving some time if I check this, that's true. If I can just go and if sum of gas and cost is smaller than 0, then return -1. Let's submit this. Did a little bit better, but it's not significant. Then starting station can be determined by starting at some station A, say. They're all reachable. Answer is if now station between A and B. Okay, that's what we did. We reset the tank to 0, repeat. What does this work? Well, let's just check if for some reason this is a lot faster than what we did, and then let's try to understand. No. Well, it's just 100 milliseconds. Like, it's not like a big difference. Like, we went from 1160 to 1062. It's not that much of a difference. It just puts us into 65%, but it's still the same thing. So it's not like a big difference. I think our logic is good, and I'm happy with what I did. So thanks for watching.